All right, so next we've got Guillaume, who's going to talk to us about reverse proxy.
Hi, everyone. Awesome. So today I want to talk about reverse proxy. So I don't really have a presentation. I'm going to show you some code and like some actual use case that we use at my company, Simple Wage in New York. So here we have a simple example of a very, very basic reverse proxy. So what does it do? It's from directly the standard library. We create that reverse proxy object, and we are going to tell it what to do through that director pattern method member. So in that director method, it is a very simple example. I just tell the reverse proxy to go from this host to localhost on 1991, and it should be a simple proxy. So I'm going to try. So this is a small, a very small HTTP proxy server, which is going to display its port and its URL. And here, I'm going to run that simple proxy, which does not work, of course. And here it should be good. So now I have the reverse proxy running and a small HTTP server. So I'm going to call curl. And as we see, I called the port 1990, which in turn called the port 1991. It is very, very useful, very practical. However, in a more advanced situation, we might want to have multiple hosts, and we, more importantly, want to have availability. So in order to do that, we cannot really play too much with director, because director does not handle the dial. However, because the standard library is pretty nice, if we look at the reverse proxy, we can see that we have a transport, which is going to be used for the HTTP request. And inside the transport, this is where all the magic is going to happen. So if we look at a more complex example, so this is directly coming from our repository. So I have a small controller that I'm going to use to hold my registry endpoints. So this is a fairly basic example. I have one service called test1 with version 1. I have 3 endpoints. I'm going to give that registry to my controller, and then to create the proxy and to listen on 7070. If I look at the controller, it's going to be fairly basic. I create my controller with the registry, so this is what I'm going to use later on in order to load balance where I need to go. And more important, I'm going to display my transport. So that transport, because I put it inside the controller, it's going to be unique. So each time I'm going to call my reverse proxy, I'm going to always use the same transport. And this is very important because it allows us to do like persistent connections. If we create a new transport each time, then we're going to do a new connection each time, and we would like to avoid that. And I'm going to go through the proxy and dial a bit later. First, I'd like to make a small demo. So I'm going to start the same HTTP server as before on 3 different ports, the 3 different that I have hard-coded in my load balancer, and I'm going to run it. So if I go, I can see it always goes to 80, 82. It is not really load balancing, but if we look more in depth what's going on, it shows that the reverse proxy is going to handle a pool for us and is going to use persistent connection. So the first time we came in, we created that connection to that particular host, and then we just reuse the same persistent connection. If I kill that server and try again, we go to another one. And once again, if I kill that server, we go to the third one. So it is smart. It knows when the connection stops and is going to go to the next one. And if we want to have a little bit more fun, we can start a curl in background and to load a little bit the reverse proxy. And when we do that, we see that it does go everywhere, and is going to, because when you have one connection in use, the reverse proxy is not be able to use it again, so it's going to create a new one and to add it to the pool. So when I just do one curl at a time, we're going to reuse the same persistent connection, whereas when I do a lot of curl at the same time, it goes everywhere. So how does it work exactly? If we go to the proxy handler, so this is our main endpoint on the registry, on the reverse proxy side, we are going to do a simple reuse the path that we have. Extract service name is a small helper that is going to take the service name and service version and to give it to me. Then we have the same director as we had before, which is not very helpful, but with a small trick, I'm not going to use an actual host. I'm going to use that service name and that service version as my host, and I'm going to explain why later. And then I create that reverse proxy. So each time we create a new reverse proxy, but because the transport is part of the controller here, it is the same one, and this is what allows us to do persistent connection. Then, if we look at the proxy, so remember that we have on the host only the service name and the service version. In the proxy is the last thing that is going to be called before the dial, and here I'm going to construct the actual endpoint URL from this. So if we look at the load balancing part itself, it is very, very, very smart. We first do the lookup on our registry. So in that case, in that demo, I just made a small map that is very basic. In production, we have a zookeeper cluster with that holds all our discovery. And after that, once we have the list of endpoints, I'm just simply doing a random and try. If it fails, I try again until either it works or it fails. And as long as we have live host, so we are never going to lose a connection because of the single transport. And each time we have an host that gets lost, the connection is going to get dropped, and we're going to call dial again. And so that way we are sure to never lose any data. That's about it. So if you have any question, thank you very much.